Hello all, my name is Matt Hudson, aka the IT Alchemist, here from Ultima. I'd like to introduce you to my extended series of short technical videos talking about hybrid IT infrastructure. Through the series, I'm going to be introducing you to a bunch of IT infrastructure technology that at Ultima we think you should be considering for your cloud, data center, network, and workspace. The series will consist of bi-monthly 5 minutes so kind of video blogs detailing a single technology from my IT Alchemist periodic table, what the use cases are, how it works, and what's so good about it. I'll be introducing some of my colleagues as well at times, and some vendors, just to talk you through the technologies and to talk you through potentially what they can do for you and your business. We'll also have in the future technical deep dives into some of these technologies, where you can see under the hood the hardware and software in way more detail. You may be wondering why it's called the IT Alchemist, except for the obvious reason I'm stood here in a mock-up of a chemistry lab. But the reason why science was always a bit of a passion for mine, particularly chemistry. Growing up, I went on to do chemistry at university, and later on I moved into IT, where actually I'm somewhat better at. So I thought I'd combine those two things, and you'll see from my periodic table of IT is almost identically aligned to how the chemistry periodic table is. So I'm going to take you through those groupings within the periodic table over the next few months and maybe years, and go through each of the technologies and also talk a little bit about my chemistry love. So back on to chemistry, let me tell you something. The first thing I learned about chemistry all those years ago is do not trust atoms. They make up everything. Anyway, join me for my first video blog, where I'll be talking through HPE disaggregated hyper-converged infrastructure. I'll tell you why it has a daft name and also a difficult name to say, but also why it might be the perfect combination of traditional style 3-tier architecture and hyper-converged. If you love storage, hypervisors, and compute as much as I do, then you'll love it. Give me a minute or two to prepare my lab and we'll kick off. I hope you enjoy it. Today we'll be looking at HPE Nimble dHCI. This technology sits within our hyper-converged and converged stack in our table and replaces the element boron, atomic number 5. Unlike boron, Nimble dHCI is incredibly common and doesn't require a supernova to exist. So, on to the 4 big questions. Number 1, what is it? Number 2, what are the good, the bad, and the ugly points regarding Nimble dHCI? Number 3, what are the best use cases for it? And number 4, why does it have a daft name? So let's tackle number 1 and number 4 together. So Nimble dHCI is essentially your classical 3-tier architecture. So you have your storage, you have your compute, and you have your network switches. And essentially, you deliver that in the disguise of hyper-converged. So it has all the feature sets, the kind of easy scalability, the easy setup, and the easy management that you expect from that. But actually, ultimately, fits in the converged area where it's a kind of single vendor delivered approach. So onto why it's got a daft name. So the D in dHCI stands for disaggregated, and it doesn't stand for daft. But what that means is we have all of the features and functions that you'd get from hyper-converged infrastructure, but not some of the drawbacks that you get from it as well. And you get all the easy scaling, like I mentioned earlier. So as you can see from the diagram, I've kind of listed up the classic makeup of the different approaches here: the 3-tier architecture, the converged architecture, and the hyper-converged architecture. The 3-tier, so you have your servers, which have a hypervisor generally installed on there, and you have your network switches, which are deployed by your network team, and then you have your storage, which is deployed by your storage guys. The converged area is pretty much exactly the same setup. The only difference here is generally with a converged setup, you have a single vendor approach this, and it's kind of more of a closed system. But that does mean is you are able to then deploy it as a single system, scale it as a single system, and it gives you a bit more easier management and so often kind of a turnkey approach to deployment. And then the hyper-converged area, ultimately similar to that converged. The only difference is really at that point is the storage layer sits inside of your hypervisor, or sits inside of the compute units anyway. So you put storage inside of your compute nodes, and then you can scale your storage out by adding more this in your compute nodes, or you can scale your compute out by adding more compute nodes, or you can do the both at the same time. So add scaling and add for storage and add scaling for compute as you add more nodes and scale it out. And again, you've got your network, which generally at that point with hyper-converged is normally separately deployed, but intrinsically linked to the hyper-converged infrastructure. So with Nimble dHCI, what we have is a 3-tier architecture, which is kind of managed in a converged setup without the converged challenges around vendor lock-in across the entire stack. But also you get all the advantages of hyper-converged with all the feature set. And those advantages take me to point B, or point 2 within my previous setup. So the good, the bad, and the ugly. So my viewpoint is there are a number of key reasons why people buy hyper-converged. The 4 key ones are able to scale storage and compute easily and independently. The ease of setup and the speed of setup as well. So we can deploy these hyper-converged architectures incredibly fast into data centers. Sometimes we're talking a number of days instead of weeks and months. Then we have the ease of management and the ease of scaling up your team to be able to manage this environment. And then we have finally the 4th key reason is the lower total cost of ownership. So we kind of combine with point 3 there. So we have fewer skills, less touch points, fewer things that are more of a closed system, so fewer things that can go wrong, which means it's easier to support, and there's fewer skills required to support it. You don't need a network admin, you don't need a storage admin, and everything can, in theory, be managed from your virtualization layer. Nimble dHCI delivers all the stuff that we just spoke about, that hyper-converged delivers, but also it kind of delivers a little bit more that the traditional stuff used to deliver. So you can scale the storage independently of the compute area. You can scale the performance of the storage by adding more storage nodes or by adding more power for storage controllers. You can scale the compute by adding more DL servers, and you can set it up incredibly quickly because it's a kind of a turnkey solution. So it's very similar to how you would your hyper-converged and converged. And again, you can scale quickly by adding more nodes, and there's a single kind of process to be able to add more capacity within each of those areas. Setup of platform is very quick. Management is simplistic, and which basically means lower total cost of management going forward. Really decent stability and uptime. And when we talk about the TCO, it's very similar to the hyper-converged area. You also get a tool called InfoSight. If you're not aware of InfoSight, go online, Google it. It's an incredibly powerful machine learning AI-based management tool and support tool. It tells you about your environment, it tells you what's going on, and it even kind of diagnoses issues outside of your core environment. So it might tell you that your VMware is misbehaving, or a virtual machine is performing badly. So you get all that via a single stack from HPE. A little top tip here from the Alchemist. If you are looking at deploying Nimble dHCI or any kind of solution where you've got a single compute kind of hyper-converged setup, maybe even storage as well, where a 3-tier, I highly recommend looking at the same switch brand that you're deploying for your compute area. So the reason I say that is as we move into from 10 gig connections into 40 gig or 25, 40 gig, or even up to 100 gig, these GBICs, these fiber modules to be able to connect your environment into your switches, obviously you have to buy one for each end, become incredibly expensive. By buying, if you're buying HPE hardware and you're buying HPE switches, you can use DAC cables or TwinNet cables, which are probably about 4 times cheaper than buying the GBICs themselves, but are supported fully within that platform. So HPE to HPE, Cisco to Cisco, you can use DAC cables. This is going to save you, if you look at a hyper-converged environment, it's probably going to save you about 5 to 10% per node on that GBIC cost. And onto the bad. So for starters, it's VMware or nothing. It's also iSCSI or nothing. So if these two things bother you, either of them, I'm not sure why iSCSI should nowadays. It's fast, it's reliable, it's stable, pretty low latency as well. For most workloads, iSCSI is perfectly good. So if you're not a VMware house, you don't want to be a VMware house, and you don't want to use iSCSI, then this is a non-starter. Look somewhere else. There's no real backup or DR built into the platform as well. So you get like snapshots like you would with any storage platform, but you don't get kind of that fully end-to-end backup and disaster recovery kind of setup you would with like SimpliVity or Nutanix. You do get synchronous replications. If you are doing something like active data center setup, a metro cluster, then you absolutely can use these things for that, and it's incredibly good. And the great thing about it is it's free. You don't have to buy additional software or additional hardware to be able to provide that. Some more bad stuff. It takes up slightly more room in your racks than hyper-converged, because for starters, you have the storage, you have to rack, but also it's a DL360 or DL380, which means there's a 1U server or a 2U server per box. So you can't get the density you can with some hyper-converged. So with things like Nutanix, for example, you can get 4 nodes into a single 2U box. The ugly, let's skip past the name, although yeah, dHCI is not really a very descriptive name. I would call it something like modular converged infrastructure. But the reason I call it something like that is it is similar to converged infrastructure. So you get that 3-tier architecture with a single kind of vendor stack, but and it's a kind of a closed system. I.e., if you want to buy another compute node, it has to be a DL380 or DL360. If you want to buy more storage inside of there, it has to be Nimble. Or it can be Ultima, but that's for another day. But it's not fully closed like some of those converged infrastructure. For example, you can use the storage for servers outside of the dHCI infrastructure. So you can connect the Nimble that's inside dHCI to a server such as SQL or whatever it might be outside of dHCI, which kind of gives you that flexibility to use it for additional items like physical servers. You're also able to use like vCenter for connecting to other clusters. So it's not a closed system where that vCenter can only manage the dHCI environment. It can manage multiple areas as well. So it's not fully closed, it's a semi-closed system. So still onto that good, bad, ugly stuff. dHCI is, like I said earlier, a VMware only platform, which does mean that kind of you get that, what some people might call a hypervisor tax, which is a challenge. Some people don't want to pay into that and use hyper-converged infrastructure running on Hyper-V or potentially Linux, something like Acropolis with Nutanix. But if you are a VMware house, actually dHCI is a step above hyper-converged, and I'll go through a diagram right now and tell you why. The hyper-converged has many great things going for it, from its footprint size, its easy deployment, its scaling and management, of which dHCI can get pretty close, if not match, most of these areas. But its core issue with hyper-converged over the 3-tier architecture is that with a 3-tier, you have a storage device that's designed specifically for storage. It has specific compute performance there, it has memory designed, and it has cache designed there to perform storage I/O. Unlike with hyper-converged, where you're essentially sharing your compute and memory from your compute nodes to provide storage I/O. This is not ideal for the 2 reasons. One is performance. If you max out your performance on your compute nodes, you lose the ability to have storage I/O, or seriously degrades your storage I/O. For you chemistry buffs out there, it's a bit like the Heisenberg uncertainty principle. You cannot know both the energy and the position of an electron in the same way that you cannot service a storage I/O at the same time as servicing a compute I/O. This means that generally you're more likely to overegg the amount of CPU and potentially memory as well into your cluster, just in case. So you've got that extra headroom not to wipe out your storage when your compute gets heavy. Which leads to number 2, the licensing. If you're using VMware and Microsoft platforms, which most people are, and if you're using SQL Enterprise at a core licensing level, which some of you are, you'll be licensing the core or socket level of your hypervisor environment. So if 5 to 10% of your CPU is being used to provide storage I/O and for managing the hyperconverged infrastructure itself, you're paying for licensing that you cannot use for your VMs. You're essentially costing you an extra 5 to 10% of additional licensing, as well as cores, to be able to provide that area of compute. So not only are you paying extra VMware licensing, you're having to pay additional Microsoft licensing for Windows Server, and also you're providing potentially SQL licensing and any other kind of device that you're running on that platform. So that's kind of a long-winded way of saying, if you're a VMware house and you're also a Microsoft house, then really you should give dHCI a look. So just to sum up those use cases we spoke about, and to wrap all this up, if you require synchronous replication, you get it free with Nimble dHCI. In fact, you get all licensing for free. So you can consume it as and when you need to, not having to pay those nasty uplift costs for if you want an additional feature. If you have vCenter existing, or you want to use vCenter for multiple clusters outside of dHCI, or migrate away from existing vCenter clusters, then this is again a decent product for you, because you can integrate with other areas outside of Nimble dHCI. The storage options are just vast. You can start with hybrid, you can do all flash, you can go all NVMe, a mixture of those. You can start from 11 terabytes all the way up to 1.5 petabytes. It really is a huge array of options. You can have multiple arrays in a single dHCI platform, and you can mix and match things in and out as you wish. And also you can use that storage for other things outside of the dHCI cluster. And just like most hyper-converged infrastructure, it's easy to manage. So customers with limited skills can operate, maintain, and support this platform via a single interface, can scale it as and when they need to, and it's all backed by that single vendor-based support. So hopefully it's been useful, and hopefully I'll see you next time when I'll be checking out Cisco Umbrella with my good friend, Professor Chris Watkins. Now, thank you all, and thanks for joining me.